Saxon Algebra 2, Lesson 55. This is a two-topic day. Both are algebra. Have you noticed that the geometry lessons have kind of petered off and gone away? I'm not mad about that. We've got the trig, our sine, cosine, tangent, all that good stuff. That to me feels a little different. I'm not mad that we're not calculating surface areas and volumes anymore. That got a little old for me. But today we don't have trig either, pure algebra. We're going to talk a little bit about advanced abstract equations. Don't you feel smart when it says advanced in the title, especially when it's something abstract equations? That already sounds hard. But advanced, whoa, look out, smart person coming in. There isn't really anything new that we're going to say. The problems are just a little bit crazier. Remember, with abstract equations, we're dealing with mostly letters. There might be a few numbers thrown in, and John has to tell us what to solve for. If he didn't tell us, or someone didn't tell us, we would have no way of knowing what to do because it's just alphabet soup, right? I think that's all I need to say. Yeah. There are equal signs, so we can eliminate the denominators, and that is one of our first steps. We will eliminate denominators. I'll use my shortcut that looks like demons. And then the other thing that we'll remember to do early on in our problems is eliminate parentheses. All right? That gives us a pretty good strategy of how to start. So let me flip over and let's take on good old example 55.1. How many are there? There are 3 of these, and then there's 1 of the other section. John tells us solve for m. Thank you, John. Otherwise, we wouldn't know. That's why I write this here and circle it, is to remind me, oh yeah, that's what I'm trying to do. I know you know this, but remember to copy everything that, if I write it down, you write it down. Pause me if I go too fast. Now John has this, and then on the other side of the equation, he just has a plain letter K, and he's got it floating. You know how I feel about floaty things. Most of the time, it's just annoying. So I'm gonna put K over 1. I like the look of that much better. All right, I said that as a first step, eliminating denominators is a good way to go. So that's what we're gonna do first. We're going to eliminate the denoms. And remember, we do that by using the least common multiple. Least common multiple we can only get by multiplying. That's what the M stands for. So x times m times 1. The 1 I can ignore. And I'll just write that in alphabetical order. And then I write this up here, don't I? That's how I always do this, so that I know what the heck I'm doing. This is where I write my LCM. Then I'm going to cancel, and I'll eventually have to multiply. Okay, here in my first one, I'm going to put parentheses around this because I don't want this getting messed up. And I can cancel the x's. That means that I'm going to have m times the quantity a plus b. Okay? Plus, now the m's cancel, and I just have an x times a y. No binomial business to deal with. Equals, we can't cancel anything, so we have to keep the m and the x. I'll put them alphabetical, k, m, x. Oh, that was nice. Our second thing that I mentioned on the other page is eliminate the parentheses. Okay, so that's easy. We just distribute, right? We've been doing that since we learned how to walk. I'm going to go alphabetical. AM plus BM plus XY equals KMX. Okay, now, I didn't give us any more insights, but you'll remember we want to gather the desired letter on one side of the equation. Our desired letter is M, so let's look where the M's are. 1, 2, 3, right? So, you can do this however you want. You can swim these terms around however you like, as long as you end up collecting all the M's on one side and the non-M's on the other. Do whatever makes you happy. I'm going to move him this way, and I'm going to move him this way. So, and I'm going to illustrate to you how we don't necessarily always have to write it out. I'm going to copy this, AM plus BM. This, when we change sides of the equation, we change the signs. This is positive, so I can just make it KMX. And then same for this. When I change sides, I change signs. So it's minus XY. Oh, that's nice, isn't it? All right. Now we've got all of our M's on one side. Then we factor. And what I mean by that is here where we've got all the M's collected, we're going to factor out that desired term. What we'll have left is the A plus the B minus KX, and that equals minus XY. Beautiful, right? Now, the last step, divide. And notice these steps are exactly the same. All of these steps are the same as what we've been doing for abstract equations. John's throwing us more complicated expressions. All right, now we can divide this whole puppy dog away. A plus B minus KX over A plus B minus KX. Whoops. Now, I'm going to use this problem to illustrate something. This all cancels, so now we can write our answer as M equals minus XY over A plus B minus KX. Now, that's not wrong, but a lot of mathematicians, myself included, think that it looks messy to have this minus sign up here. I don't like the way that looks. So what I would like to do is multiply the top and the bottom by minus 1 to make that go away. It's just messy and I don't like it. So when we do that, and I'm going to be careful to put this in parentheses, this becomes positive. So I'll have just a nice neat XY on top. I like it so much better. But I have to multiply top and bottom, so that means I have to change all these signs down here. So it's minus A minus B plus KX. For reasons I can't readily articulate, minus signs down here are not as annoying. The minus sign up here was really ugly and annoying. So I'd rather put up with this than that. This then is my final answer. Pretty sure John does this too. Okay? If you were to leave your answer as that, and you went to the solutions manual to check, you would find that your answer didn't look like John's, right? Well, what you would have to do is compare and realize, oh, he got rid of that minus sign. So what if I try multiplying my top and bottom by minus 1 and see if I get the same thing, all right? So it's your job to keep fighting to figure out how to make your answer match to John's. Don't just give up. If you think it looks really close, don't just give up. Get in there and see if you can make yours match to his. All right, there's the first one. Woo! If you don't feel smart, you need to call me, because anyone who can do a problem like this is really flippin' smart, right? And if you can follow along with my notes about the different steps, you are doing great. We're in the middle of Algebra 2, you guys. We are in the big leagues. I'm not kidding. Next problem, example 55.2. Did I mention that there are 3 of these? Yes, I did mention that. I just mentioned it again. Okay, ready? Solve for x. Again, we would be lost if somebody didn't tell us what to do. We would just sit there staring at the problem, drooling gently maybe. I just looked at Gracie, so that's why I thought of drooling. She's sleeping on the floor. She's happy because she got a lot of salmon skin tonight after dinner. That is an E. These problems are really good at making us unafraid of lots of random letters. And then again, this is a floaty D, but I'm gonna fix it and put it over a 1. Don't like floaties. Okay, lots of letters, alphabet soup, no numbers in sight. There were no numbers in the other problem too. Sometimes John will just toss in like a 1 or a 4 just to make it fun. Okay, 1, eliminate the denominators. Find the LCM. C times X times 1. Well, that's pretty easy. It's just CX. Multiply every term by CX. And then we start canceling and simplifying. The C's cancel, so I'm going to write MPX. I like alphabetical. X's cancel. Now we have to be careful because this is a quantity, so I'm going to write plus C times the quantity D plus E. There are some parentheses. We'll get rid of them on the next pass. Down here, nothing cancels because it's a 1, so I'll have C, D, X. All right, eliminate our parentheses. Easy. That's a plus sign. All right, get all the desired variable on one side. So let's find out, there's an X and there's an X. All right, I would like to move him over here. We'll let these guys stay on the left because there are 2 of them. We'll just bring him over here. So I'll have CD plus CE equals, CDX is staying put, change sides, change signs, this will become a minus. Good, right? Now we factor. The other side just waits patiently while we factor our X out. CD minus MP, and then we divide. We divide by whatever is chilling next to our desired variable. And what I'm gonna do, that all cancels and we say equals X, but I'm just gonna write it again over here so it looks a little neater, and then I can box my answer. Okay, no reason to copy it all over again. Notice that this term, numerator and denominator, or this answer, has a CD up here and a CD down there. Oh, we'd love to cancel them, but we cannot cancel when we're adding or subtracting. If possible, we would factor the CDs, the C or the D out, but we can't. There's no way. We could factor out the C, but that wouldn't get us anywhere. So this is the answer. This is the best we can do. CD plus CE over CD minus MP. Just double checking to make sure I got it right. John does not go alphabetical. He's kind of a free spirit that way. And I would agree, they don't have to be alphabetical, but it's just easier for me to manage everything if I keep it alphabetical. One more. Do you feel advanced? You should. These are super hard problems. Example 55.3. John says, solve for A. Again, this letter on the other side is floaty. I'm putting it over a 1, so it looks more organized. One of the things I want to just point out to you about these problems is that when we begin, we don't really have to worry about where our desired letter is. Look, this time it's buried in the denominator in a quantity with a B. We don't care. We don't even think about that in the beginning. Don't even let that worry you, all right? One of the things I want to help my students with, I've talked to a number of you about, is overthinking problems. And that's hard for me to teach around because I don't know what your brain is doing to overthink. but I do know what it feels like to overthink. I used to overthink too. And in some ways, that's cool. Overthinking is kind of cool because it means your brain is digging deeper than it even needs to, right? It's aware of more subtleties. But this is a classic area where I would say, don't worry about where that desired letter is or what it's doing. Just follow the first couple steps. Just follow the steps and it'll all sort itself out, all right? So it's a fairly mechanical process. Number one, eliminate the denominators. Find the LCM. This time our LCM has a quantity in it. All right, we can do that. Y equals A plus B. Does it matter that our desired letter is in the LCM? No, not at all. Don't care. So now I'm going to multiply Y times the quantity A plus B all the way across. Now we'll go back and cancel and simplify. The Y's cancel. So here I get mx times the quantity A plus B, right? Don't overthink that either. These guys are on the outside, those are on the inside. Just leave them like that. Plus, now the A plus B quantity cancels. That's nice. D times Y equals, now here nothing cancels, and again, don't overthink this. Those two just go together. Py times the quantity A plus B. Okay, first step, eliminate denominators. Check. Second step, eliminate parentheses. Oh, okay. We can do it. Now, this isn't necessarily getting harder, but this one's kind of messy, isn't it? We got a lot going on here because of these quantities. But that's okay, we can handle it. AMX plus BMX. Any of you guys have BMX bikes when you were younger? Those came out when I was a kid, and I lived out in the country on a lake in Michigan, and we had lots of woods and meadows and trails to ride around, and riding BMX bikes around was totally my life for a while there. AP plus BP. I like to make up names for the terms. Amex, BMX, D, AP, BP. Okay, cool. We've got rid of all our parentheses. Now we're going to swim things around so that all of our quote-unquote desired letters are on one side alone. Our desired letter is A, so let's find them. There's an A, and there's an A. Oh, well, we've got a little bit of work to do, don't we? I'm going to send him over here and this one over here. All right? I'm not going to write it down as an algebraic step. I'm going to use my brain. This one's going away, so I'm going to have BMX plus dy, and then this one will come over. He's positive here. When he changes sides, he will change signs. That's really a challenge for me to say. So it'll be minus BP. And then on the other side, my AP stays the same, but then this one will come over. It's positive here, so it'll become minus AMX. Whew, I feel good about that. Now I'm going to factor out, so I'm just going to copy all of this. That's the same. Now on this side, I just do a quick little factor out of my desired letter. Py minus mx, and now I divide to get, right, I'm getting that by itself. Py minus mx, this whole thing, oh my gosh, Py minus mx, right? That's easy. I'm canceling this, so my A's by itself. None of this is going to cancel, so I can just write equals A. I just bring the A over here so there isn't such a giant mess. I don't want to rewrite this if I don't have to. Let's check the answer. John says it's PYB minus BMX minus DY. Wait a minute, all his signs are opposite. Time over mx minus py. All of his signs are opposite than mine. What the heck? Well, once again, that's not a surprise. All it means is that he swam things in different directions than I did. That's all it means when the signs are off. But I want to make sure mine comes out exactly like his. So I'm going to multiply minus 1 over minus 1. And because we're doing top and bottom, we don't have to do it to the other side. So we'll get A equals minus BMX minus dy plus BP over minus py plus mx. All right, I don't really like the way this looks. I could bring the positive terms to the front. That would look a little better, but I'm not going to go to all that trouble. Let's just check and make sure that these are the same. Now I'll read you. Positive PYB. Okay, there it is. Positive PYB minus MBX. Okay, I have BMX, but that's a minus dy. Check. The top is all good. These all made sense. Same signs, same letters, different order. And then in the numerator, positive mx minus py. Okay, that works. So, while this answer is equally correct, this one matches to John. And you know, that's my goal in life. I want to match to John because he's a cool kid. I wish I had met John Saxon in real life. You know I'm his biggest fan and perhaps his alter ego. And I do feel that he's here with us at all times. And when I get to heaven, man, I am going to run to wherever it is you go to find people. And I am going to meet John Saxon and say, dude, thank you. And I'm sure you will too. Thank you, John, for the endless years of entertainment. Okay, those are our abstract advanced equations. Let's move on and get our second part, which are word problems that generate quadratic equations. I'm sorry. Word problems that lead to quadratic equations. That means we're going to get x squared terms. Okay? When we have squared variables, that's quadratics. That's an S. Okay. We're only doing one, but let me show you how it works. Find 3 consecutive integers. Remember these problems? Such that the product of the first and the third is 4 greater, blah, 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 blah. I'm not going to read all that. All right, 3 consecutive integers. We remember how to set up the variable for these. The first one we'll just call n. The second one we'll call n plus 1. And the third we will call n plus 2. There's 3 consecutive integers, right? Remember, sometimes we'll get consecutive odd or consecutive even, and then we have to skip numbers, but that's not the case here. Here we just have 3 consecutive integers, so the first one will be n, second n plus 1, third n plus 2. Okay, good. Such that, let's go back to the drama of this. The product of the first and the third, product means multiplying. So the product of the first and the third is greater than, and I'm not going to read you the number of how many greater than. It's greater than 4 times the second. The second is n plus 1. Okay? The product of the first and the third is greater than 4 times the second. Make sense? Now, we need the number to bring this back into balance. But we look at the sign to help us figure out, what are we going to do with that extra number? Well, we can see this is greater than this. And I always like to adjust this side because I have room to write right there. I'm very practical in that way. This I see is the smaller side, so I'm going to add, and our magic number is 4. Okay? Please, 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 always write the inequality first. I guarantee you'll get the problem right every time. But if you try to do it in your head, We all mess it up. I am reviewing with one of my older students right now for something she's doing in college, and she tried to skip doing the inequality. She's like, oh, I know these problems. I'm familiar with these. We're just reviewing. I can do it without the inequality. She would get it wrong every time. So then she went back to doing it as an inequality, and she got it right every time. I was like, dude, it just doesn't fit in our heads properly. This isn't like a babyish thing to do. This is how I do them too. All right, now we've got it all set up and we're ready to work on solving. And the first step will be to do these distributions. And here comes the drama. Ready? N squared plus 2n equals oh my gosh. Really, John? So as soon as we see this and we see that it's not going to cancel out, there are some problems where we'll get the n squared on both sides and it'll cancel right out. Bring everything over to one side and let's turn it into a proper quadratic and go from there. So I'm going to swim this n across, and then these two go together to make 8. So I'm going to subtract 8 from both sides too. And I'm going to keep that in order. That goes, that goes. So now I can say n squared minus 2n minus 8 equals 0. So here we are with our quadratic equation, right? I warned you that we were going to get to a quadratic equation. We have an n, not an x, but same difference, right? So now what we do is we sit here and we pray, please, John, let it be solvable by inspection. Please don't make us do the man-eating dragon. Please, 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 please. By the way, I saw a meme on Instagram tonight that was talking about how the text said, my high school physics teacher warned me that the college instructors were going to be way more serious. And this was a video of a college instructor, a college physics instructor, right, who supposedly is going to be so serious and somber, ranting on and on about a velociraptor being part of the problem. So I felt very comforted that perhaps your professors will not be as shocked about the man-eating dragon as I sometimes fear. So I guess you'll just have to let me know if your college math professors talk about weird things like I do. I hope they do. It makes it way more fun. Okay, but the good news is we do not need to invite the man-eating dragon into this. We can solve this by inspection. There are indeed two numbers that multiply to this and add to this, and I'm going to give you a second to think about them. And right now I'm wondering, are you really thinking about them, or are you just waiting for me to come back? I don't know. But the numbers are x minus 4 and x plus 2, right? Because they multiply to -8 and they add to -2. Yay! So now we can quickly solve these because we know that either x minus 4 equals 0 or x plus 2 equals 0, right? That's the zero factor theorem. And then we know that x equals 4 or x equals -2, right? I'm just doing the quickie algebra there. So when we come back to our list, we can see that the numbers are either -2, -1, and 0. I don't know why I picked that one first. You'd think I'd pick that one first, but I didn't. Right, so I'm plugging the -2 in here. Oh, this should be n. I changed it into an x, sorry. I'm a creature of habits, but these are our n values, right? Let me just change that so it doesn't make you crazy. These should all be n's. And then the other option is 4, 5, 6. So what we found is there's actually two sets of consecutive integers that will satisfy this condition, and we've described them right here. And our work is done. One thing I want to point out is that when I defined our variables, I wrote first, second, and third by them, so that when we were matching these variables into this equation, I wouldn't get confused, because if I don't write this down and it says the product of the first and the third, I tend to want to choose this as the first because of the 1. And I call this one the second. So it helps me to write their names out here so that I will pull the correct variable when I'm setting this up. So I do recommend that you take a second to scribble first, second, and third by these. It makes it a little bit easier to go through this. And then please, for the love of all things good and holy, write it as an inequality first, then fix it so it will be an equation. Please, I beg of you. Okay, that is the end of lesson 55. And I have to say, I just looked ahead, and 56 is old school geometry. Brace yourself. Okay, that's all though. That was a fun lesson, wasn't it? I enjoyed it thoroughly. Thank you, goodbye.